Here my screen. Can you see my screen?
Yes, sir.
Okay, cool. You haven't done this problem yet. You are a bit lagging behind. So let's just see or just recap what we have done with this code earlier. Okay. So there are bags. You can use the bag to store items for which the user of the bag will give max number of items at construction time. That means the user of this bag class will specify the maximum number of items that you can store in this bag during the construction of bag object. Okay, then you can then retrieve items from the bag. An item has a name and a price. Okay, so there is an item and each and every item has a name and a price. Okay, caps, notebooks, pens, lipsticks are all items. Means there is a relationship between item class and all these items. Okay, cap is an item, notebook is an item, pen is an item, lipstick is an item. Okay, so that what we should do, how should we implement this?
Extends to item.
Yeah, first we should create item class which has name and price that we have done previously. Like, yeah, item has a name and price. And now we are now the requirement is telling that pen is an item. So pen extends item, and during the creation of pen we receive the name and price, and the same constructor we do have in the item class to set for name and price, and we'll send both of these name and price to the super constructor. That means to the constructor of item class where this is being done. What are we doing here? We are validating the name for null and not an empty, or only empty string, only empty spaces. We should not have that. And then putting it to the name, and then we are validating the price and putting it into the price of the item. So the same thing we are doing both in cap and another item do we have. I'll create one more, which is that item, bag notebook. We'll create a notebook .java. So, and notebook is an item. So we will extends item. Okay. And what it should do, why are we getting this red line error? Why this error? We have to provide what? We have to provide a
Parameterized constructor.
Yes, we have to provide a parameterized constructor and call super of by passing that those parameters. Or we need that is not a mandatory thing to create a parameterized constructor, but it is mandatory to call the super constructor by passing some parameters, because one cannot create the object of item class without passing any parameters, because we have only one constructor in that item class which accepts parameter. So what we should do, we should create a constructor and call super of. This will fix the issue. Clear? In super constructor, we are setting for name and price. Since item has name and price, notebook also has name and price. Got it?
Yes, sir.
Okay, cool. So we'll go to back class. Okay, so we have item class, we have caps, notebooks and pens and other items. A bag can be used to search for a given item. You can request the bag to give you the total of prices of all the items in the bag. Write a tester class to test creation of bags items and then add items and everything we will do. Okay, so in this class, I'll just copy this, copy, paste. Okay, I have back copy.java. I'll just rename this. Bag collection.java. And I rename this class to bag collection. And I copy, paste to the. So now, where do you think that we can use collections in this class and optimize our code to perform in a better way? Where do you think we can add collections? We can use collections, and what kind of collections that we need to use? What do you think?
We can remove the concept of.
Yeah. Yeah, go ahead, Anant.
So we can remove the concept of max items when you're using collections. You can just keep adding and removing it.
Okay, but there is a requirement that we during the initiation of bag, we have to give the max number of items that we can store. How can we satisfy that requirement?
Just have a condition when you're adding and check whether it's the maximum number has been reached.
Correct. Then which collection should you use instead of what?
You can use ArrayList or linked list, any list. Instead of arrays.
Correct. Everybody with me? Do you agree with this, or do you have any other inputs? Someone else was trying to answer. Hello?
Sorry, my internet was unstable. Instead of item of, we can use collection, sir.
Yeah, okay. Correct. Everybody with me? Everybody with Anant? That instead of arrays, we can use collections. What collections should we use?
Any list.
Lists. Yeah, any list. Here it doesn't matter much. We'll use ArrayList itself, okay? Because all the lists, because we will have a small amount and we will not remove or add items in between. That is why linked list is not necessary, but we need to access items randomly. Okay, so it's better to choose array list instead of this item class. Sorry, item array. So how should I go about coding it? I should create a reference of array list coded to what? It can store what, or it should store only what? Items. Correct. So I'm getting an error because I should import it. Import ArrayList from java.utils package. And then here, what we should do, now can I store a string into this array list?
Yes.
Items dot add ABC, items dot add XYZ. So I can store string, I can store int, I can store double, but I do not want to store all those rubbish things because I need this array list purely to be a container for items. So we will use items as the generic, item as the generic. Okay. Now the Java allows, or Java compiler or tests what kind of items are we going to add to this item array list. Okay, items array list, and then checks for that. If we are trying to add anything else than item, it will throw an error, compile time error. Okay, now we do not have this array itself. Now what we should do, here, we are initializing to item, right?
New array list of.
Yeah, we should initialize it to new array list of. Okay, we'll save this. We should receive the max items, but we cannot restrict Java array list to contain this number of items, but we can restrict while adding the number of items. We can add that number of items to the array list, checking the size of the array list, or how much ever size it is there. If the maximum size is reached, then we should end the adding of the array list. For example, how do you think we can achieve that? What we should have an extra? We should have an extra what? Private int max item. Okay, and we will not check this. Sorry guys, I have some throat issue. Okay, so max items greater than 0, then you tell this dot max items equal to what? Max items, and then items equal to new array list. Why am I checking this? If the max item that is sent through the constructor is greater than 0, then only I should initiate max items to the max item that is sent, and I should create items array list object. Okay, else what we should do? Else what we should do? Is this okay to just SOP? Hello?
Except
Or throw an exception.
Yeah, we should throw an exception. We should not do this. So how can we do that? Do you remember? How can we throw try catch? How do we throw an exception?
throw new
Throws
legal
keyword.
argument. Throws.
Not throws. Throw. If you do not practice, you will forget. Throw new what exception? What exception is this?
Illegal
input argument.
Yeah, illegal argument exception, and we have to pass a string. Okay, so we have to pass a message telling that the max size of the bag should be more than 0. Got it? Any doubts? Any doubts, guys?
Awesome.
Clear? Everybody? Okay, cool. Now we have to refactor this store item thing. You are going to tell me the code, what I should do. How should I invoke the behaviors of constructor to add an item? What are the validation that I should do? What actually the code is to store an item when I send an item to this method? Hello?
You can check if items dot remember its size of is less than the max length, and then you add the item using the dot add method. Else,
Good.
you can throw maybe a custom exception.
Correct. Good. Before that, we are missing something else. Shall I remove this code? Earlier we were using array. We had a count variable. Now we do not need this count variable also, because the array list itself counts how many items that are being stored in the particular array list. So that we get from the size method. We will remove this count also. Okay, save this, and I'll just remove this implementation. Okay, and what we should do is, if item not equal to null and not item, items, item not equal to null, correct? Items dot size of should be less than max items, then what we should do is
Items dot add item.
Items dot add of item. Okay, so the best way is to put this here. Okay, and put it here. Cut this, just tell you why. Okay, if item, the past item is equal to null, what we should do? Else throw new illegal argument exception by passing a message cannot add a null item to the bag. Okay, and if it reaches the max items, or yeah, the size reaches the max items, then we should stop adding and do what? If items dot size less than max items, then do this, then add item to the array list. Else what we should do? Else what we should do?
Throw one more exception.
Stack overflow.
Yeah, which exception?
Sir, I don't know, sir. Maybe custom exception.
No, yes. We should throw a custom exception. I want to have that as throw new bag overflow exception. And reached max size of the bag. Cannot add more items. Okay. Yeah. What we should do in this bag overflow exception? Do you remember?
Have a parameterized constructor.
Yeah. We have to create a class called bag overflow exception that extends what?
Exception.
Exception. Correct. Then inside that class, what we should do?
Print status.
You have to have a parameterized constructor.
One
Yeah,
empty
we should
constructor.
have. Yeah, we should have two constructors, one parameterized and another empty argument constructor. In a parameterized constructor, what we should receive as a parameter?
A message.
Message, a string. Correct. So we'll create that class. Create class bag overflow exception and save this. We'll go to that. See, we have this class and that should extend exception. Okay. And inside this, we should provide two constructors, public bag overflow exception message, and we should call super of message. And one more constructor we should have, public bag overflow exception, and we will have empty body, empty argument list constructor. Clear? This is a recap of how we create a custom exception. We will create a class that should extend exception class, and here we go. We accept a parameter for one constructor as a message and we pass it to the super class, and bag overflow an empty argument constructor with empty body so that we can throw this exception both by having or passing the message or without passing the message. Clear? What happened? We should add throws. This this particular method throws the bag overflow exception. Clear? Any doubts here? I'll just recap. We are checking whether the sent item is null or not. If it is null, then we'll throw an illegal argument exception, passing a message, cannot add a null item to the bag. If it is not null, then we are going to add the item to the bag or to the array list by calling the add method only if the size of the bag is less than this max items. Okay, that is set by the user during the creation of bag object. Okay, if the size has reached the max items, then if user tries to what? Add new item to the bag, we will throw an exception, and that is a custom exception, which is bag overflow exception, and we'll give a message. And to throw this, we have to create this class on our own, give two constructors as an implementation, one to accept the string as a parameter, one is an empty body. And since we are adding this throw, we should add this. Since this is a checked exception, we have to add this throws clause in the method header. Clear? Okay. Hope this is clear. So now, how should we implement this search item method? what should we do? Earlier, we used to iterate over the array and search for the item name in all the array, like getName dot equals. Then we used to return that particular index of that particular item. Okay. Now what we should do using collections?
Contains.
Yeah, correct. Good. We are having a method called contains. It will return Boolean, but if I want to return the index,
Iterator.
no. Want to return the index. Index, guys. Answer in the
Index of
question. Yes, index of. Use the index of. What we should receive?
Item name.
Item name.
receive an item.
Yeah, we should receive an item. It's okay if I want to receive an item itself. How can I implement this? If I receive an item, it's really very easy. I receive an item, and I just return what? Return items dot index of item. Okay, this is enough if I want to return the index of that item here. Suppose if I want to receive a item name, okay, I have a overloaded method where I do not have this. I have a string item name, and I want to return the index of this item which contains this item name as the index value. How should I do this? Hello? Easy, guys. It was there on the screen 2 minutes earlier. We have to do what?
Iterate over the list and
We have
find
to
the map.
iterate over the list, find if that item has this name. If it has that name, then just return the index. Like what? If, sorry, for each item in items, okay, if item name, sorry, if item dot get name dot equals item name, then do what? Then do what?
Return index of.
Yeah, then do this. Okay. Else, not else, sorry, else return -1. Got it? Any doubts? If we are searching for the item with the particular item object, then this is sufficient. This one line of code is sufficient. Suppose we do not want to have an item object or item reference to be passed, we need to search against the name of the item. Then we should iterate over the array, so array list, then check whether that item contains the item name. or both of them are equal. If it is equal, then return the index of that particular item. Clear?
Yes, sir.
Okay, cool. Yeah. Retrieve item. How can we refactor this? I want to return an item. What is the method that we have in collection so that it returns an item? And that is done on item name. Should be fast, guys. What is that? Need to get the item from the array list. What is the method? Answer in the question. Hello? How do you retrieve an element from an array list? What is the method? Yeah. Is it by index? Is there any overloaded method? It returns an index, right? Get returns an index. Item, sorry. Items dot get index. Okay, we do not have, we cannot pass a string here. Okay, like item, we cannot pass item name. We cannot pass this. We can only pass the item, but I need to retrieve the item itself. I do not want index. How do I do that? We just did it. Just see this implementation and check what you can do to get the item. What you should return instead of what?
Instead of index, we should return item.
Correct. Good. Guys, are you all with me? Are you all getting this? Everybody else? We should iterate over the array, array list. Array comes to my mouth. Okay, we should iterate over the array list and return item. Okay, if we do not find the match, return null. Clear?
Yes, sir.
Okay, cool. Then we should get the individual price of the item by passing the item name. Same implementation. What we should do? What we should do?
Return item dot get price.
Yeah, return item dot get price. Just copy this. Don't you think we are repeating the code in each and every method?
Yes, sir.
What we should do then? Item dot get price, or else return 0. How can we refactor, or how can we do not repeat ourselves?
By creating a specific method.
Correct. And that method should do what?
That method should call in all other every
True or
method.
false?
Yeah, no, that method. What are we actually doing here, guys? In search item also, we are retrieving items. Okay. In get individual item price also, we are retrieving the item and then calling the item, right? Then calling what? Get price, then returning item. This is what we are doing, right? Even in search item. So what we should do is we have to call the retrieve item. Okay, I'll just do this. Retrieve item string name. Okay, what it will return? It will return an item if it finds an item, else it will return null. Okay, if retrieve item and pass an item name not equal to null. Okay, or I'll just save this as a parameter so that we can reuse that. Item equal to retrieved item, retrieved item. Okay, if retrieved item not equal to null, if retrieved item not equal to null, return items dot index of item, index of retrieved item. Okay, else now you are not repeating the logic here, and here you have to do the same. Copy this, get individual price, paste it here, return items, return retrieved item dot get price. Clear? This is how we reuse the code for retrieving item both in search item by name and get individual item price by passing the name of the item. We are trying to retrieve the item by name and then return respective values, so that we will use the same method for retrieving item, same logic for retrieving item, and then check whether it is retrieving null or not. Then we'll return this thing. Okay, so should we return -1 or what else should we do? What else should we do? Hello? Hello? Hello, guys. Are you all there?
Yes, sir.
What we should do? Is it okay to return -1? Hello?
You can return -1.
Is that expected? Is it okay to return null if you do not find item?
Yes, sir.
No, it's not.
Sorry, it's
okay.
not okay. You have to raise an exception, I guess.
Yeah, you have to throw an exception. What exception?
Item not found exception.
Yeah. So how do you do that?
Create a new class, extend it to exception.
Custom
Add-
exception.
Okay. But How do you write code here? Just write this. Throw item not found exception.
You can have an if condition. If item is equal to null, and then you throw an exception.
Which item?
Okay, you can
You are
have
on the
a
grid.
you can have
Yeah.
a temporary flag variable, and then you can use that to
Yes.
check.
Yes, correct. We should what? Have a temporary Boolean variable like item found, Boolean item found, which is initially false. Okay. If this is true, set this item found to true. Item found, sorry. Equal to true. Okay. Then if even this will not and you have to create item found equal to true and then return item. Okay. Is this okay? This will not work. How we should do is item retrieved item equal to null, and we have to do this. Please bear with me. Retrieved item equal to item if retrieved item, sorry, is this RI retrieved. Okay, if retrieved item not equal to null, then return retrieved item, else throw item not found exception. Okay. And you have to create this class. Throw new item not found exception, item not found, and item name. Okay. And you have to create the class. Create class item not found exception. And inside this, you have to give two constructor bodies. Okay. And replace it with these names. And it should extend exception. Clear? I've done so many things here, and you have to add the throws.
So is this the best way to satisfy the requirement?
Yep.
Okay, sir.
Because it is the best way to code. The requirement is not telling that you have to throw the exception if you do not find the item. Okay, but you should throw the exception instead of sending the null value. Okay, you think user is expecting some value from the method. Okay, he wants to retrieve the item. If he doesn't receive, or if it doesn't find that item, it should respond with some message, right? Exception will not, first thing, it will not allow your program to crash. Second thing, it is helpful to give some valuable message to the user that it did not work. Instead of sending null, we will send the what message that item did not found. Even for this, the exception is useful because at later point of time, if the operation depends on the returned value, if it is a null value, later point of time you will find the exception that some kind of null pointer exception may occur because this returned the null value. That is the reason that we should not, now onwards, we should not return this kind of values from our methods. Okay, even though requirement did not say that you should throw the exception, we should, as a better developers, we should throw the exceptions whenever these kind of scenarios are there. Clear?
Yes.
Okay, cool. Now here, what happened? Yeah, even here it's giving an error. Why it is giving an error?
You need to catch the checked exception.
Yes, we need to catch or duck the exception. Okay, we will also add throws clause. Even this will throw the item not found exception when we ask for an individual item price when it does not exist. Okay, even here we might be getting the same exception. So even here we will add throws clause so that even this will throw the items not found exception, item not found exception. What happened? Okay, got it. So clear? Everything clear till now, everybody? Okay, cool. Last but not least, get total price. We have to add the total price of the item and send the total price. Okay, we will do this. We will what? How do we do that? Can we use for each loop?
Yes, sir.
Yes, we can use for each item in items. We will have total price plus equal to item dot get price. Okay, that's, we'll just remove this and return total price. That's it. Clear? This is how using collections, like earlier we used to use the normal for loop where to get individual price of the item. Now we are using for each loop by which only we can get the price of each item and add to the total price. And here it's more efficient now. We are just using the same code, same logic to get each and every item, and we check for that and we return the price. If we do not find it, we'll throw the item not found exception in each and every method where it is a kind of searching some item. Okay, that's it. And even here, if item is there, it returns -1 if it did not find. So this is the implementation of Java, guys. We cannot change that. So if it is -1, then item is not there in that index, in this array list. Okay, then we have store item. We checked for null and we checked for size and then add the item. If we did not, if we do not have space, we are throwing some exception. This is how we create bag and behaviors of the bag. Now we will test the bag and we will move forward. Okay, go to the test method, test bag. Okay, we were discussing about this. I'll just comment this out, save, and I create cap, I create pen, and so, okay, I do not create any of the item. Okay, I'll just delete this and I create bag. Okay, and I give maximum number as 5 to test. So first item, cap, I create multiple items like this. I create a notebook, book equal to new notebook of, and some book and some price 50. Okay, and I just copy this, paste, and book 1, book 2, 3. Okay, I copy this. What happened? We have this pen 1 and pen 2. So I have created these many items. Okay, now I am adding these items to the bag. 1 item I add, 2 item I add, 3 item I add. I save this. And how to print? How to print the number of items here in the bag? We'll create a method to print items in the bag. How do we do that? Public void print items, not receive anything, and we'll just print the items. What do you think will be printed?
ArrayList.
Hmm?
List of items.
List of items. In that list, what will be printed?
The toString thing of the items.
ToString of the items. Do we have that?
ToString of ArrayList.
ToString of the array list. In that array list, what will be printed? Okay, we'll just see that. Then I'll just call, I call store, and I call mySutarplins dot print items. Okay, we'll run this. There are no compilation errors. What is this? See, what is this?
It's the original implementation, I guess.
No, array list, it should print the list of the items. When we print some array list, it should print the array list, right?
Yes.
But why it is not printing? Just where is the back class? Store item itself will print and see.
Add collection.
Correct, correct. So it is just close all these things. Okay, in test bag, we have to create bag collection and save. I'm getting an error. Why?
Add collection Minecraft row.
We have to,
Type
yep. Okay, we created it in bag, I think. Yeah. Now, why am I getting this error? Store item is what?
You need to catch the error.
Yes, store item is throwing an exception. We have to surround it with try catch. So do this and okay. We'll save this and come back. Clear the console and run. You see, thing happened. Why? Why? It's print items. Okay. The bag and bag collection is causing the problem. Just do this. Copy. Paste. Close this bag. And then come back here. Clear the console and run it again. So what are we getting here? Yeah, it is the confusion of bag and bag collection. So we are getting what implementation of toString?
ArrayList implementation.
No. Yes, this is ArrayList implementation. This particular cap at, pen at, notebook at,
address. It is written here.
it is the implementation of object class toString. So what we should do, we should
It should override the
override
toString method.
in which class? Ideally, in which class? We should override toString method. What is the best practice?
Item class.
Item
In
class. In both.
both item and bag collection.
No. In each and every class that we code, we have to override what and all methods?
ToString method and equals method.
We have to override toString equals and hash code. We'll talk about that. These three methods we have to override in each and every class. Okay. So how do we override? You use this, we can generate toString. Okay. So this is how we override toString item name price. So since pen is an item, cap is an item, notebook is an item, we have to override all these things in all the classes also. So we'll just copy this and paste it in pen and every classes. Save. Save. Okay, and even in notebook. Why am I getting this error? Why am I getting this error?
Name is private in
Name
item
is
class.
private in parent class. Then how can I get the name?
Yeah.
How can I get the name? Just by calling get name and get price. Okay. This is what you should do in each and every class. Get name and get price. And even here we should do get name and get price. Cool. Clear? Now if we go and run back this, just clear and so items, this item contains name, cap and price, item name pen and price 100 and item name book and price 50. Now I try to add more items here. Okay, I'll just Control C, Control V, and I just copy this. Okay, just remove this. So how many items can I add to this bag?
5.
I can add only 5. Now if I run this, what happens? What happens? I get 5 items added to the bag. Now I try to add another item which is exceeding the limit of the bag, and I run this. Now you see, so you get an exception. Reached maximum size of the bag, cannot add more items, but it printed all the 5 items that is added to the bag. Clear? This
Yes, sir.
exception will not allow us to add more items than that is allowed to add. So this is how the store items work. And if we search for the item, just do search. Just do this. So search, sorry, isotarpaulins dot search item. I pass this book 3 and also I sys out isotarpaulins dot search item and I search by string and I search by pen. What happened? The surrounding. It is inside catch block. Why it is? Okay. Okay, cool. Why are we getting this exception? Even though it is in try catch block, why is this red line? Fast.
It's a particular exception you're not catching.
Yeah, we are not catching what exception?
Item not found.
Item not found exception. So we'll catch a generic exception so that we'll just Control Z and we'll catch generic exception, save this and run. Just clear the console and run it again. So here itself it got stuck, it did not search. So we will just do this, save and go back and run it. See, so the first book 3 is not there because we have not added book 3 to the bag. Okay, that's why it returned -1, and the search item of pen returned 1. That means in the index 1 the pen is there. So index 0 is the cap and index 1 is the pen. Clear? And we will also print out each individual item's price, one or two. Okay, save this and get individual item price of pen and get individual, just copy this, price of cap. Save this and we'll clear the console and run this. Okay, even pen is 100. See, item cap price 100, item pen price 100. So we got this and we'll also print out the total price of the items that is there. Total items price, and we save this and we should not send anything. What happened?
Spelling.
Get total price. Okay, so just run, we'll just clear the console and run it. See, total price is 300, 100, 200, 50, 50. Clear? So everything is working perfectly as expected and we tested. Is this clear? Any
Yes, sir.
doubts in creating the bag with collections, adding items, retrieving items, searching and throwing custom exceptions as and when required? Everything is clear?
Yes, sir.
Okay, this is what I wanted to discuss today, mainly to use collections and start working on collections to add items, retrieve items, search items. Okay, then we'll go for, shall we go for the new topic? I'll just give you an overview of how to use sets, same methods as we have in the list, and that's it. Okay, then we'll end the session. So as you know, we have iterator class, and collection implements iterator. Both iterator and collection are interfaces, and we have three main data structures that is inherited from the collection. What are they?
List, set,
List,
queue.
set, and
Queue.
Correct. So we saw the list, we saw ArrayList and linked list. These are the main implementations of list. These are the classes. List is an interface, set is an interface, queue is an interface, and also we have stack. Okay, stack is also and I don't think stack is an interface. I think stack implements list. Okay, I'll see that. Okay, like this, we have this kind of data structure. In that, we have a set. Set is a separate kind of data structure which gives the implementation, which is also an interface. And we have three kinds of sets. We have hash set, we have linked hash set, and we have tree set. Okay, these are the three implementations of set data structure. Okay, so in that we have hash set. Okay, this hash set is implements set and internally uses hash tables to store data. Okay, I'll just give a glimpse of what is hash table. This is why we have to override hash code in each and every class that we use, because while using hash set compares this hash code. Hash code is something is an int value, okay, that is generated over the state of an object. As we represent string using string method, as we represent or as we compare two objects using equals method, in the same way we have something called as hash code to generate hash code on that object using the state of that particular object. Okay, we'll see in the next session how to override hash code method. So when you use hash set, it creates some tables that is called as hash tables, and these data that we are going to add to this hash set is compared with this hash code. Okay, this set of hash code should go into this table, this set of hash code go into this table, and the unique feature of the set is that it will not allow duplicates. If already a hash code, the same value like hash or same value of hash code is already present in the set, it will not allow this particular element to be added again to that particular set. Okay, this is the unique feature of set. It allows only unique elements, no duplicates. Okay, hash set uses hash table, which compares hash code or which uses hash code to store data. And another set is linked hash set. Even this is also backed by hash table, and both hash table and linked list gets combined to create this particular data structure, which is linked hash set. In normal hash set, no order of entering data is maintained. It is scattered. Okay, it is scattered over the hash tables. We will not get the particular order of insertion. But in linked hash set, you get the benefit of both linked list and hash set. Okay, there you get the ordered order of insertion intact, and also that allows that doesn't allow duplicates. Okay, and tree set uses internally the binary search tree to store the elements, and this binary search tree works as you have a parent node and you have child nodes, and the left child node, it is also called as red and black tree or binary search tree. So you have parent node, the left node will be greater than the parent node and right node will be lesser than the parent node. Like I'll just write it here as a comment. You have node 1, okay, and you have node 2 and node 3. Okay, one parent node can have only 2 child nodes. That is why it is called as binary search tree. And node 2 value will be always greater than node 1, and node 3 value will always be lesser than node 1. And what is the use of, or what is the this should be in tree set. I'll put it in. What is the use of this is it maintains or it gives the sorted set. If you need anything to be in the sorted order without any duplicates, you use this tree set. Okay, we'll just look into the methods. Let me put this into tree set class. Okay, here we create a set object, and same add method, we use add method to add elements into the set, and we can just print out the set to print all the elements of the set, and we have contains to check whether a particular element is there or not, and remove as we have remove in the list, and we have size, we have is empty, and we have add all. By creating new set, we can add all of the particular one set to another. It will add only those things which are not there in the earlier set. It will never add, sets will never allow duplicates. This is a very important thing to remember, and it is a power of this set to use. Okay, now you think I'll just give an example. How do you get the unique words of a sentence, of a file? And you can use this set. Okay, you just add all the words to a list and add that list to the set. It will have only unique words of that particular file. This is one example of using set to store unique elements and to have a better performance on adding and removing things. We use sets. Okay, hash set, no order of insertion and no duplicates. Linked hash set, no, has an order of insertion, no duplicates. Tree set, order of insertion is also there, no duplicates, and at the same time a sorted set. Okay, so you keep this in mind, make it as a note, or I'll just make it as a note and I will send it to you. Okay, and you have remove all, and you have iterator. This also I wanted to talk about, not go in deep. We have something called as iterator interface, and we create iterator, and set has its own iterator method. Okay, so we create an iterator and it returns an iterator object. Okay, when we call iterator method on set, it returns an iterator object. Using that iterator object, we can, which exposes so many behaviors. We can call those behaviors and use that iterator to iterate over the set. Okay, it is just to use those behaviors, and we can iterate over the sets even using for each loop. Okay, then we have clear method which clears the data. The same way, trees, tree set also same methods, add, and especially it has the first element. To return the first element, it has first of, last of, and also it will return an element which is greater than or equal to this element, which is called as ceiling of. And it has floor to return an element which is lesser than or equal to this element. Since it is a sorted set, we have these kind of behaviors over tree set. Okay, then we have subset. We can retrieve a subset using subset method, which also what returns a set. We have something also called a sorted set class. Then that's it. Size is empty, which all we know. Iterating and clear. And linked hash set, same add method, like add and then remove, then contains, set is empty, size, everything that we have seen so far in all the classes in linked list, array list, and these things also have. I'm repeating this just because you get familiarized with the method names and try using these things as and when it is required. Clear? I'll just send this code and please check these methods out and run this code, understand this code, what are all the methods and what it is doing, and you can come up with any doubts that you have. Any doubts you have?
So no doubts, but I'm not at all clear. I need to see it, sir. Very confused.
About what? Any specific?
About all this
confusion?
hash table, binary
Okay.
tree, all these things, sir.
Yes,
Yeah,
sir.
you will get
Same
it
here.
cleared. Okay, cool. I have not touched anything internally or internal working.
Will you
We'll
explain
see
again
that.
or it is the last?
We will see that, but you will get more clarity if you watch collections videos in the portal.
Okay, sir.
It is all there, how it works and everything. Hash table, hash buckets, everything is there. We'll see even that. I'll ask Vikram sir. I think he was thinking to discuss about that internal things, internal stuffs. If he tells me, I will just carry on that. Okay, it is just like linked list. We know how it works. In the same way, linked hash set, there are some hash buckets kind of things. The code that we generate out of hash code method in each class is compared while adding into the set. Okay, that's it. It's not a big deal. We'll discuss it in detail if needed. Okay, but be comfortable in using these methods. That is what is required the most, but it is also required to know the internal working of data structures. Clear?
So what is the major three? What is the major difference in these three?
Okay, hash set, I told you, it doesn't maintain the insertion order. Okay, linked hash set maintains the insertion order. Tree set will give you the sorted ordered set. Okay, these are the main three difference between these three sets. Hash set will not maintain the order of insertion, and no duplicates. No duplicates is common for all the sets. Okay, but no insertion order for hash set. Insertion order is there for linked hash set, but no sorting. and tree set will have insertion order and also it is sorted. Okay, you add one element to the tree set, there will be only one element. You add another element to the tree set, and sorry, there is no insertion order in tree set. So if the second element is lesser than the first element, then it will add it as a right node. As I told, if you are adding, you have added 2 as the first element, so it becomes the parent node of first parent node of the binary search tree. Then you try to add 1. Okay, so 1 is not greater than 2. That's why it is added as the what? Right child node to this particular node. Okay, then you try to add 3. So it will add 3 to this, 3 as the left child node. Okay, then you try to add what? Again, you try to add 2. 2 is less than 3. So it will add it as the right child node of this node. Okay, then you try to add 4. It will add it as left child node of this node. Like this it works. So here you get the sorted order of the list. So since 2 is already there, it will not allow duplicate, so it will remove this. So now you get the sorted order. When you print it, it prints from 1, 2, 3, 4. Got it?
So what I understand, so we maintain a balanced binary tree here in tree set, is it?
Yeah, yeah.
Okay.
Balanced binary search tree.
And there is no insertion order will occur in tree set.
No. It will add things by sorting things.
What if you want tree set with a descending order?
You have another method like you can reverse or something like that. No, you have some other classes called as comparator and comparable. You can alter the way of adding things to the set.
Right. So by default, it is ascending.
Yeah, by default it is ascending. What it is doing, guys? Can you mute? What it is doing is it compares. So you have added 2, then you are trying to add 1. So it compares whether 1 is greater than 2 or not. So in all the sets, hash set, linked hash set, and tree set, comparison is a kind of thing that works. It compares before adding. If it is already there, the comparison tells that it is already there, it will not add. If it is not there, it will add. That means there is something called as some middle agent called as comparator that is doing the job. We can order the way, or we can manipulate the way of comparison and then try to add things. We'll see even that, how to alter the way of comparing things and adding to the set. Clear? Is it clear?
Yes.
Okay, cool. So this tells that you are not watching the videos on portal. If you do not watch videos on the portal, you are the loser. You have to watch videos on the portal in order to get very good clarity on the subject. Okay, this is just a recap session to make you familiarize that what are all there in that particular class, and how you can use these kind of demo sessions to get hold on topics and to get the clarity on topics. You have to watch videos in the portal that Vikram sir tells. Otherwise, you are the loser. Got it? Okay, cool. Anything else?
No.
Okay. Cool. Thank you. Thank you then. Shall we end?
Okay, sir. Bye-bye.
Okay, bye.